we have a cone. And what are the properties? A cone, this particular cone is a right cone because with a vertical height in the exact middle and a slant height. So a cone has a radius at a perpendicular height to the radius and a slant height. Now if you look carefully, you can see a cone has two faces, the circular base and a curved side. So to get the formula, we know the circular base is a circle, which is pi r squared, and we know that the lateral face needs to be worked out. And if you split this lateral face open, if you use paper to form a cone and you split it open, you get a sector. Or if you like, just draw a circle, cut a sector out of it, you'll be able to fold it back into a cone. Now, this sector will have the radius of L. So the radius of this sector is different from the radius of the base. And the formula for this sector is given as pi r L. And I'm going to try to go through a little bit of proof to explain to you why we have pi r L. Now, when you split it open and you form a sector, that is the circumference of the circle. So if you like, you can cut a circle, make a sector out of it and fold it into a cone. And you see that when you open it up, this bit would definitely be the same as the circumference of the circle. So the circumference of a circle is actually 2 pi r. This radius is with respect to the base circle. So in actual fact, the actual area of a sector is given by the angle over 360 times pi times L squared. The formula is supposed to be r squared, but in this case, our radius for this sector is L. That is why it's L squared, not r squared. Now, given this as circumference, we can form another expression in terms of L. This is circumference in terms of r. We can find in terms of L, because looking at this line is a fraction of a full circle with a radius L. And that fraction is angle over 360 times the circumference of that full circle, which is 2 pi L. That means these two should be equal. So I'm going to equate the two expressions, the two formulae, and this is what I'm going to have. Now, I want to find an expression for L so that I can substitute into one of the L's here. So I'm making L the subject. That will give me 362 pi r over 2 pi theta. Crossing out the common ones, L represents 360r over theta. So if I replace one of the L with 360r over theta, I'm going to have a formula as this. 360r over theta is what represents L, and it's L squared, so there's another L left. Crossing out the common ones, I'm now left with pi r L, which is our formula. So the lateral curved side of a cone is given by pi times the radius times the slant height. So now the total surface area of a cone is the area of the base plus the area of the lateral curved side, which is given by pi r squared plus pi r L. So this is how the formula comes into being. So let's look at an example and use the formula.